Okay, in this lesson we're going to look at using compound interest formulas and evaluating functions with the base e. And I hope you had a chance to read some of the quotes that I have on this first page. I thought they were pretty funny, and also kind of express the power of compounding when dealing with interest and investments. But let's first start by looking at a simple interest problem. And simple interest, basically the formula for this is very simple. It's just that your interest is a product of the principal, which is the money that you borrowed or the money that you invest. Obviously, sometimes you're paying interest and sometimes you are earning it. R is the interest rate as a decimal, and T is time in years. And so let's start with the first question here. Example 1. Find the interest charge if you borrowed $2,000 at a simple interest rate of $6,000 per annum for 2 years. What will you owe after 2 years? So the first thing we need to do is find the interest. And we know the interest equals the principal times rate times time. And the principal is $2,000. That's the amount we borrowed. The interest rate is 6% or 0.06 as a decimal. The time is 2. And we can multiply this out on our calculator, or this one you could probably do in your head, but we'll pull up the TI and do this out. So we take 2,000, multiply it by the 0.06, multiply it by 2, and we get our interest, which is $240. And then to figure out how much we owe, we would just have our $2,000 plus the $240 at the end of 2 years, so we would owe $2,240. Now, I'd ask you to just pause the video before you try the next problem, and then once you get your answer, turn the video back on and check your answer and see how you did. Okay. So this problem, we're asked to find the interest rate if you invested $2,300 for 4 years in an account that earns a simple interest, and you earned an interest of $178. So again, we're going to write down the formula. Interest equals principal times rate times time. And this time, R is our unknown. We don't know the interest rate, but we know the principal, which is $2,300. We know the interest that we earned, the amount was $178. We don't know R, and we do know T, which is, since it's 4 years, we're going to multiply by 4. Right? So what I would do first is I would multiply the 4 times the 2,300, and you get 9,200 R equals 178. We'll divide both sides by 9,200. So R is going to equal, we'll pull up our calculator, and we'll take the 178 divided by the 9,200. Right. And so we get 0.01934. We certainly don't need all those decimal places. So if we say we round it out to 2 decimal places, we would say that the interest rate is approximately equal to R is equal to 0.02 or approximately 2%. Okay, so on the next page, and most or many investments do not involve just a simple interest, but a compounded interest, where you're earning interest, and then that interest then becomes part of your investment, and now you earn interest on that interest. And so there is a proof here that I would be posting a video explaining the proof. We're not going to prove it right now. And in this class, you won't be asked to prove this, but it's nice to know where a formula comes from. So I encourage you to, go to the Blackboard website and look at the proof that I've got posted in this unit for this. But here's the proof just laid out for you. We're going to skip over this for now and just jump right into using the formula for compounded interest. And so it says here that most banks have plans in which interest is paid more than once a year. And n is the number of times interest is paid per year. So if you compounded semi-annually, n would equal 2. Compounding quarterly, n would equal 4. Monthly, n equals 12, etc. So we're going to use a compound interest formula to calculate A, which is the amount after time. And so here's the example. It says you decide to invest $8,000 for 6 years at a 7% per year, compounded monthly. Use the compound interest formula to find the value of your initial investment after the 6 years and round your answer to the nearest cent. So the formula for compounded interest is right here. This is it's A equals P times 1 plus R over N to the NT. Again, if you have a chance to look over that proof, you'll see where this formula comes from. And so our job right now is to figure out how do we use this formula and how do we enter it correctly on our calculator. So we want to identify the different variables. And so since there are more here, I'm going to list each one. So A is our amount, and that's actually what we don't know. That's what we're trying to find out. Okay, the question said we want to find out how much the value is worth after 6 years. That would be A. P in this case is equal to 8,000. R is our interest rate, but again, always as a decimal, so 0.07. Compounded monthly, which means N is equal to 12. Okay. And so what we're going to do, and also we need T, right? So T, we've invested for 6 years, and T is 6. So our job is to basically substitute into this formula and then evaluate it on our calculator. So P is 8,000. 1 plus R over N, so it's 0.07 over 12 to the 12 times T, which is 6. And so before you type this into your calculator, you never want to round until the very end of a problem. So before you type this in, I would simplify as much as you can. But we're going to rewrite this as 8,000 times 1 plus 0.07 over 12 to do the 12 times the 6. So we're going to evaluate that at 72. And we're going to type this into our calculator, clear out what we had there before. So we're going to take slide this up a little bit. We're going to take the 8,000. We can, on the TI, we can type this in almost exactly as you see it. Open parentheses, 1 plus 0.07 divided by 12. Close the parentheses, and then there's a caret key here, which we've looked at before with exponential functions. We want to raise to a power of 72. And then we'll hit enter. Right. And so they want us to round to the nearest cent. So our answer is 12,160 and 84 cents. Okay. So at this point, I'd like you to pause the video again so that you can try one of these on your own. And then, so I'd like you to do this problem below here. And then once you get your answer, I'd want you to start the video up again and check your work. Okay, so in this case, we've got a problem that is going to be compounded daily. We've got an amount of $12,000, 8% annual interest rate, and we want to know how much is in the account after 5 years. So I'm first going to write down the formula. And I'm going to start identifying what my different values are. So we don't know what A is. P is 12,000. Got 1 plus 0.08, which is our interest rate. N is the number of times we're compounding, and since we're compounding daily, we're going to do that by 365. And then we're going to have N times T, which is 365 times 5. And so let's pull out our calculator to evaluate this. Clear that out. And on this one, I'm actually not going to evaluate the exponent first. I'm going to show you how, if you don't want to do that, how you can do it on your calculator, but you have to be really careful with your exponents. So I'm going to type the 12,000 and open parentheses, 1 plus 0.08 divided by 365, and we're going to raise that to the power. And there's different versions of the TIs. So my version is a little more advanced, and so it automatically assumes that everything's up in the exponent. When you use the caret key, you're going to need parentheses. So I'm going to put them in to stress that. It's going to be 365 times 5. All right. And then we'll hit enter. Okay. And so we can see here that, and we're rounding this one to the nearest cent also, so we're going to have $17,901.11.